Hi, we're here once again and we're going to learn about horizontal asymptotes this time. How can our knowledge of limits be able to help us identify horizontal asymptotes of given functions? So let's get started. All right, so here is our definition of the horizontal asymptote. So a line y is equal to k is said to be a horizontal asymptote to the function f of x if and only if one of the following is true. The limit of the function as x approaches negative infinity is k, or the limit of the same function as x approaches positive infinity is likewise k. All right, so in other words, to check whether a certain horizontal line, y equals k, is a horizontal asymptote, we just have to check the limit at infinity. If the limit at infinity is equal to k, then that horizontal line is a horizontal asymptote. All right, let's see how this definition is used um, in the first example. So we have is y equals 4 a horizontal asymptote to the graph of y is equal to 5 plus 4x over x plus 3. So we said, well, we just have to check the limit at infinity. Okay, for this case, let's begin our analysis with the limit of 5 plus 4x all over x plus 3. As x approaches, okay, this is very arbitrary. Let me check positive infinity first. Okay. Of course, you can on your own do negative infinity. Now, to check the limit at infinity, we ask ourselves, sir, what is the largest exponent with respect to x? In this case, x. So we multiply the fraction with the following factor 1 over x all over x plus 3 times 1 over x as x approaches infinity. Sir, this is going to be the limit of 5 all over x plus 4 x over x all over x plus 3 over x. Okay, as x approaches infinity. So, sir, this is the limit of 5 all over x plus 4 divided by 1 plus 3 over x as x approaches infinity. Okay, so we know that this will eventually be 0, and likewise this will also be 0, which leaves us with 4 over 1 or 4. Sir, the limit apparently of the function 5 plus 4x all over x plus 3 as x approaches infinity is 4. So we have satisfied already one condition of the definition of horizontal asymptotes. We can already declare, no, that y equal to 4 is horizontal asymptote to the graph of y equals 5 plus 4x all over x plus 3. I will leave it to you for your exercise to check the limit of the same function as x approaches negative infinity, whether you can reach at the same conclusion. Okay, right. So let's go to problem number 2. Is y equals to 2/3 a horizontal asymptote to the graph of y is equal to 2x squared plus 1 all over 3x squared plus 2x minus 1. So the same, we check the limit of 2x squared plus 1 all over 3x squared plus 2x minus 1 as x approaches. Okay, this time I want to check at negative infinity. Okay. um, Again, we ask ourselves, sir, what is the largest exponent with respect to x? In this case, it's x squared. So the factor will now change into the limit of 2x squared plus 1 all over 3x squared plus 2x minus 1 times 1 over x squared divided by 1 over x squared. Um, as x approaches negative infinity. And do note that we ask ourselves, sir, is this equal to 1? Okay, bago tayo tumuloy, before we proceed, we ask, is this equal to 1? Well, if you have a very negative large number, okay, you square that, you get a very positively large number. So you have 1 over a positively large number divided by 1 over a positively large number, which should give us 1. So, okay, we are assured that this is 1, so we can continue. So to continue, we have now the limit of you have 2x squared all over x squared plus 1 over x squared divided by 3x squared all over x squared plus 2x all over x squared minus 1 all over x squared as x approaches negative infinity. Hmm. This is equal to the limit of 2 plus 1 over x squared divided by 3 plus 2 over x minus 1 over x squared as x approaches negative infinity. And from our previous discussion, we know that this will turn out to be 0, 0, 0. So we will be left with 2/3. Okay, what does this mean? This means that y equals 2/3 is horizontal asymptote to y is equal to 2x squared plus 1 all over 3x squared plus 2x minus 1. All right. So again, I will leave it to you if you want to check if you will get the same conclusion when checking the limit of the same function as x approaches positive infinity. Remember that our definition requires the truth of only one of the two statements. So if one of the two statements is already true, there is no need to proceed with the other. It is already, or the given horizontal line is already a horizontal asymptote. Okay, let's move on to our last example. Is y equals -1 a horizontal asymptote to the graph of y equals 1 plus x to the fourth over x squared minus x to the fourth? Let's check. So what is the limit of 1 plus x to the fourth all over x squared minus x to the fourth as x approaches infinity? So again, the choice is arbitrary. Now, gusto ko naman, I want to check the limit of the function as x approaches positive infinity. Again, if you want to check this at home using negative infinity, fine. Okay, for your practice, you can do that. So we ask ourselves again, so what is the highest exponent with respect to x? Uy, this time we have x to the fourth. So what we do is we multiply this by a factor uh, by a factor which is times 1 over x to the fourth divided by 1 over x to the fourth. This gives us the limit of 1 over x to the fourth plus x to the fourth over x to the fourth divided by x squared over x to the fourth minus x to the fourth all over x to the fourth as x approaches positive infinity. Sir, this is just equal to the limit of 1 over x to the fourth plus 1 all over 1 over x squared minus 1 as x approaches positive infinity. Or, sir, this is 1 all over negative 1. Sir, the limit of 1 plus x to the fourth over x squared minus x to the fourth as x approaches infinity is negative 1. So indeed, what can we conclude? Therefore, sir, y equals negative 1 is horizontal asymptote to y equals 1 plus x to the fourth all over x squared minus x to the fourth. All right, so that means that yes, this is a horizontal asymptote. Okay, so again, I leave it to you at home to practice. Why don't you try checking if you can arrive at the same conclusion? Um, if you evaluate instead the limit of this function as x approaches negative infinity. Okay, but for now, that's all. See you next time.